Hello, everyone, and welcome to another episode of Alexa and Friends. My name is Jeff Blankenberg, and as we do every week, we have an interesting conversation with someone from the world of Alexa. Today, I have Pradeep Natarajan joining us. Pradeep, thank you so much for being here.
Thank you. Thank you for having me, Howard.
Certainly. So one of the things that we do at the beginning of these interviews to get to know the person a little bit is we ask a couple of silly questions. And so one of the first questions that I like to start with relates to superpowers. If you've seen any of the Marvel movies or DC movies that have been out recently, you're probably familiar with the concept of superpowers. But I'm always interested to know from our guests, if you could pick a specific superpower for yourself, not a superhero, but just one individual power, what is something that you might choose for yourself?
Yeah, I actually might have a very relevant to my life answer to this.
Oh, great.
I don't know if you have watched Popeye the Sailor cartoons when you were young.
Of course.
This is a person who gets tired when physical challenges come his way, and then he eats spinach, right? Which is quite healthy as well.
Yeah.
And then he gets re-energized right away. So that's a superpower I would like because as you can see, I'm getting a little older, and I recently started playing tennis again after nearly a decade, and realized that I tire much easier than before.
Yeah.
So that's a startup. That's a superpower I would love to have.
I like that. It's very close to home. I have that same feeling where, if I didn't have so much to do during the day and I couldn't just power through with caffeine, I think I would probably be ready for a nap about 2:00 every day. So I fully understand what you're saying.
Yeah.
Yeah. Well, that's a good one. All right. So your superpower would be the ability to, and I don't know if you're specifically saying that you love to eat spinach or want to eat spinach on a regular basis, but the idea that you would be able to eat something simply and then just have all sorts of energy and strength and power, right?
Yeah. Basically re-energize yourself quickly by eating something, not too bad for you in the long run.
Right. I think that's perfect. All right. This second question is requires a little bit of a story, and just stick with me. It's going to sound outlandish, but it's a fun question. So I want you to imagine you're walking through a large city, and where you need to get is 1 block over from where you are today. And if you imagine a large city, huge city blocks that you have to walk around. You notice that there is a very convenient, well-lit alley that leads you directly where you need to go. It's not a path you would normally take, but for today, it looks like a good opportunity. So you decide to head down this alley, and as you get about halfway down the alleyway, in front of you emerges a giant horse-sized duck, like a really, really large duck. And he doesn't look terribly friendly. And so as you would, you turn around and you head the other direction, hoping to get out of that alley now. Only to find that end has been closed by 100 tiny duck-sized horses. So a whole bunch of tiny horses or one giant duck. The question for you, as outlandish as this question happens to be, is which direction do you think you'd have the most success getting out, and how would you do it?
Yeah, I'm not sure what the right thing to do here is, but personally, I'm scared of birds with large beaks.
Oh, fair.
Like geese or ducks. So, I have been attacked by Canadian geese, which, some of those unfortunate things that have happened.
Right.
So definitely I'm going to avoid the duck. So I'm going to run the other way, whatever that other option is.
Perfect. A bunch of tiny horses. So it sounds to me like regardless of how many horses there are, you're going the other way from a giant duck.
Correct.
Got it. That's a good one. I tend to lean towards the duck. I think I would have a better chance with the duck, but I can see how certainly having been attacked by some larger birds, that would probably not be in my best interest either. I understand your decision completely.
Yeah.
Awesome. All right. So let's get into some more of the serious content and the reason that you're here. One of the things that I really like to share with our audience, and one of their favorite parts of these interviews, is to understand kind of where you came from. So the way I like to explain it is when you're telling your friends kind of what your work history looked like, or maybe describing it in an interview, I'd love to hear maybe where you started, where you grew up, where you went to college, and then kind of the job roles that you've had along the way that got you to where you are today. And then, of course, we can talk about what it is you do today and all those things eventually. But I'd love kind of your origin story, your history.
Yeah, absolutely. So I grew up in India, in a mid-sized town in southern India,
Okay.
and then I went to school at the Indian Institute of Technology in Chennai. Um, and I have been in computer vision and machine learning for nearly 20 years now, starting from my undergraduate project. Um, but in some ways, a lot of it also had to do with serendipitous opportunities that came my way. So to some extent, my story in computer vision and machine learning has been a bit of learning to love what I'm already doing, rather than finding what I love and then doing it.
Sure.
So and I see a lot of recent graduates and stuff who are not sure what they want to do, and I just want to say that's perfectly normal. As you walk through the doors that are open for you and dive deeper into what you are doing, you will quickly learn that there are a lot of interesting things that you can follow up. So in my case, I got introduced to CV in my junior year in undergrad, when one of my seniors, he's actually now at Amazon as well, he described his internship the previous year at an AI lab in Bangalore, and suggested trying it out. Right. So, I used to like physics in high school, and computer vision, at least how it was done back then, looked quite related to physics among all the computer science areas I was looking at. And I liked the idea of spending a summer in Bangalore as well.
Yeah.
So I started that internship, and then came back to my undergraduate school and did my undergraduate project as well in a computer vision related topic, and then applied to graduate schools. And again, I was actually lucky to get a PhD scholarship at USC at that time, as the only person with just an undergraduate degree in a lab with several other folks with lots of experience and quite seasoned in the field at that time. I worked on developing action recognition systems, which was a lightly explored area at that time. And I did my PhD in that area.
I'm not familiar. So what is an action recognition system?
Yeah, like if you are walking, are you walking, or are you running, or are you jumping, or are you doing jumping jacks? And I'm not making this up, right? The action recognition data sets at that time actually contained images of someone standing in front of a doing jumping jacks, and someone else walking. And then our goal was to build a system that can distinguish between these two.
Cool.
Right. This looks, to someone who is doing computer vision today, all of this looks quite odd. But, this was just 15, 16 years ago. That's how we were. We had a data set from the Weizmann Institute of Technology in Israel with 100 samples, and another data set that someone in KTH released with 1,000 samples. And this was the state of the art at that time. And I was working on leveraging various sequential machine learning models to recognize these actions, like hidden Markov models and conditional random fields. So I was sort of moderately successful, I would say. Not did not light the field on fire or anything like that. But at least I started with something I knew nothing about, and actually most of the community also didn't know much about, and created something coherent during my PhD. But the more important thing that happened to me at that time is I saw my lab mates doing very systematic machine learning on visual data. They start with low-level feature representation, applied support vector machines, and had very coherent baseline, how much they are improving over the baseline and stuff. And this was surprisingly uncommon in computer vision in the 2000s. Compared to other machine learning areas like speech recognition or NLP.
Sure.
So I sort of got experimental discipline during my PhD, and then the next door that opened was I got a chance to work at a leading speech and language technologies company in the Boston area, and And HMMs and CRFs and those kinds of techniques are were very popular in speech recognition at that time, and even today to some extent. And because I use the same techniques for analyzing visual data, it connected with the folks there, and I joined them and started an exploratory CV initiative. That turned out to be quite successful,
Yeah.
as we started to analyze actual unstructured web videos, rather than these videos collected in lab conditions. And I worked on various projects where we participated in international evaluations and did quite well. And I also got a hands-on feel for data and modeling problems outside of computer vision, right? Speech recognition, optical character recognition, and such, because that's what most of the folks in that company were working on.
Yeah.
And then I was at Amazon for about a year.
Okay.
Working on the Fire Phone, building optical character recognition technology. And then I got an opportunity to start a machine learning group to develop systematic trading strategies at a top hedge fund. So, I was looking to do something different from computer vision that I spent more than a decade at that point in time.
Right.
And was looking for a new challenge, and I took it. It was quite revealing in that, the data is different. The noise characteristics are quite extreme in finance. But a lot of the techniques I had previously used in other modalities, like ensemble methods, early and late fusion, wavelets, all of these translated well to that domain. And I was also exposed to a unique problem in finance, which is called market impact in the industry, which is that, you launch a trading model into the market, your model itself changes the data, right? You don't see that in other machine learning domains, right? Just because I put a pedestrian detection system or a ASR engine doesn't mean we change the way we talk, right? But in financial markets, that actually happens. And so, reinforcement learning and some of these online learning technologies are quite effective and also crucial in that data space. And then, I spent 4 years in finance, and then I returned to Amazon again and have been working on developing technologies to enhance Alexa's voice-based interactions with multisensory inputs, and also a few other initiatives involving large language models and the ability to teach Alexa directly. So that's my origin story. Yeah.
I like that. A couple of things that stood out to me there that I want to get some insight on. The first one was, you said you had initially, when you were in Boston, you were working on analyzing video, lab condition style videos, and that you started taking that to less lab setting, like, these are just freely available web video, I think is what you were describing. Did you find that was a hard transition between those two, or did the training that you did in those lab conditions kind of lead to a strong enough model to allow you to determine the non-lab condition style videos pretty well?
Yeah, actually, what I myself did with the lab style videos in my PhD were largely not useful for some of the web videos. But as I mentioned, I also learned from others in the community as well as my own lab mates on more principled machine learning approaches. And those methods were also developed on similar lab condition videos, although there was a slow transitioning happening during my PhD to test it out on more challenging videos like movie videos and such. And those techniques actually translated pretty well to the web videos we started analyzing. So, so to some extent, some of my past work and past knowledge that I had accumulated did translate. But we also had to invent a bit along the way. And in each of those cases, I really relied upon the broader community rather than any startling insight I was myself able to uncover.
Yeah, that's great. And then the other thing that I wanted to dig into was your time at a hedge fund working on the financial markets. So this is something that I talk about quite frequently when talking about ambient computing and machine learning, is that a good portion of today's stock market transactions are actually being done by models and machine learning today. And one of the things that I haven't found a specific answer for, and I don't know if you have any insight or even just an estimation on this, but do you have any idea, like, what percentage of trades at least in the US stock market are being made by an algorithm rather than a human?
Probably I don't have exact numbers, but it's a pretty significant fraction, I would say.
Would you say it's
And
50%?
it's a very significant fraction that is algorithm based. And there are strategies where you hold an asset for varying holding periods, right? It can vary from a few minutes to several weeks, right? And each of those problems, each of those settings introduce their own problems. So the thing is, if you're holding for a short amount of time, the quality of signal you can develop is better than holding something for a long amount of time, right? It's much harder to forecast what will happen 20 days or a year from now versus what will happen a minute from now. But the flip side is if you're trading fast, you're incurring a lot of transaction costs. So you're sort of juggling these balls, right? And the longer you hold, the greater the risk that some external event can impact your portfolio. So there are three balls you're basically struggling, right? What is the quality of your signal? What is the risk you are taking? And what are the transaction costs?
Yeah.
And that makes it a much harder optimization problem than if you had only two balls that you are juggling, right? It's exactly like juggling. Two balls, even people like me can pull it off, but you throw a third ball in, it becomes hard, and that's what happens in automated trading as well.
Interesting. Yeah, it's just an interesting problem set for me as I think about that specific application of machine learning.
Yeah.
Just incredibly interesting to me to think about trades being made on microseconds sometimes, just trying to catch one tiny swing and make a few dollars off of that is interesting. All right. Well, I will get back to some of the things that I had planned to ask you about. I know that you were recently an organizer for a workshop on instant level recognition, and that was at ICCV earlier this month, I think.
Correct.
So your workshop focus was on artwork and landmarks and products. Can you tell us about the workshop that you were participating in?
Yeah, absolutely. And again, there is a recurring theme I want to call out, which is that I have been in the industry for a while, but I'm drawing a lot of energy from the peers and some of the more younger scientists here at Amazon that I feel quite lucky to be a part of. And in this case, one of the scientists in the team I work with, Xu Zhang, he actually drew our attention to an important gap in the problem sets that the computer vision community overall is looking at, which is that you have object recognition and those sorts of things where there is a lot of data set and a lot of researchers are focusing on those kinds of problems, right? If you want to distinguish between a painting and a building, right? Painting is an object class, buildings are an object class, and you're learning a model that can distinguish between those, right? There's a lot of attention, but a lot of real problems we face are more at the instance level. You're not interested in recognizing a painting in general, but a particular painting, right?
Sure.
Or you take a picture in front of the Eiffel Tower or the Taj Mahal or the Meenakshi Temple where I'm from, and you want to recognize that you are in front of that particular landmark, not necessarily that you are standing next to a building, right? And this particular problem is called instance level classification and retrieval. And we decided to participate in this workshop and create a data set and sort of contribute to the overall computer vision community in improving our understanding of this particular problem. And one more interesting thing in this particular problem is until very recently, deep learning methods were not the state of the art for ILR, right? Recently, they have started showing state of the art results, but we wanted to also spark that sort of investigation in the broader community on the trade-offs between more traditional computer vision approaches versus deep learning methods when you have very few samples of the instance you are interested in, right? And this builds on two or three more successful editions of this workshop. There was a workshop in ECCV 2020 and also in CVPR 19 and 18. And those two workshops solely focused on landmarks, right? You're standing in front of the Colosseum or Eiffel Tower, and can you recognize that that is the Eiffel Tower or the Colosseum? In this edition, two more domains were added in addition to the landmarks. One is artwork, which I talked about, right? We have an image set of various paintings, and can you build systems to recognize which painting it is? And from Amazon, we also added a product database. So, again, as you would imagine, the product catalogs are pretty large, and several product categories have only one or two images. So can folks build a system to recognize these, especially in a dialogue scenario, right? So somebody comes and says, hey, show me some T-shirts. And then they say, I'm actually interested in T-shirts with collars. So the way we framed that problem was we had an initial image, and then an utterance that is telling basically the delta that the user is looking for from what we showed, and a target image. And the model we want to build is the target image consistent with what the original image was and the delta that the user said, right? Here's a T-shirt we are saying. The user asked for a T-shirt with collars, and we have an image of a T-shirt with a collar. So that's a true example. If you have a shirt as the target, that's a false example, right? And we are looking to release a large data set. I think about 2 million samples, which we shared in the workshop, and that will represent a significant scale up over existing data sets available for that particular problem. So we're overall quite excited. It's a hard, real, relevant problem, and we want to spark some research in that thread.
Very much, and it seems like there's the potential for some conflicts in those things as well, because across those three domains, landmarks, products, and artwork, I mean, it seems to me that do you find that there was any conflict, for example, between a painting of the Eiffel Tower, or did those groupings not overlap? They were three independent kind of.
Right now, there are three independent data sets. But as I told before, if you want to distinguish between paintings and a picture of a landmark, that's the classic object recognition kind of framework,
sure.
Right? So there are good algorithms that could actually distinguish between these two. So even if there are conflicts, they are relatively easier to resolve, and then we look at the instance level classification problem.
That's excellent. Very good. All right. So one of the other things that I found as I was looking you up is that you're the principal investigator for a team on DARPA's Mind's Eye project. Sorry, and that's focused on developing machine capabilities that exist only in animals, like visual intelligence. Can you tell me more about this? This sounded really interesting, but I wasn't able to get a ton of knowledge about it just in the cursory search that I was doing. I'd love to know more about this. This sounds incredibly interesting.
Yeah, absolutely. So, at that time, I was actually leading teams in two projects in computer vision. And this was in 2010, 2011 timeframe, where computer vision was still largely in the academic or a small number of industry labs sort of setting, rather than something that is now foundational to large-scale services. DARPA Mind's Eye, which you called out, was one of the projects I was working on at the time. And the other project I was working on was IARPA Aladdin. So with the Mind's Eye program, the goal was to develop the capability for visual intelligence by automating the ability to learn general and generative representations of actions. So by generative, what we mean is the model could actually generate an action rather than a classifier-based model that could only distinguish between two actions but doesn't actually generate the action from its representation. So that was one of the projects, and there also the other focus was on the verbs in the scene rather than the nouns, right?
Okay.
The Aladdin program was looking at a seemingly different problem, which I talked about, right? web video analysis and classification. So can you look at all the information in a typical YouTube video, right? The individual images in the frames, the overall motion pattern across the video, the associated audio, and any speech that might be there in the audio stream. Can use all of this to recognize, whether somebody is baking a cake, or is it a parkour video, or so on and so forth. So these were two seemingly orthogonal problems, but one of the surprises I had working on these projects was that I was able to take the algorithms I developed for analyzing the images in Aladdin, right, on the YouTube videos, and apply the same system for the more higher level analysis that Mind's-Eye was looking for, and actually get very strong results. And even more interestingly, again, I told you, I was in a speech recognition team, very strong history in that. But I took the relatively simplistic algorithms I was using to analyze the images, and I applied it on the noisy web audio, and it was actually producing very strong results. So it's pretty much the same algorithmic code to do high-level vision, low-level vision for the web videos, as well as analyzing noisy web audio.
Wow.
Right? And these were all based on a technique called bag of words that has actually origins in natural language processing. So the one difference is when you're looking at visual and audio space, you need to convert the continuous signals to learn the words. And again, there is a technique called vector quantization that was first developed in speech analysis that you use to learn the words first, and then you use the bag of word representation to apply a downstream classifier, right? And in retrospect, I didn't recognize this at that time, but all of these results were pointing to some of the largest trends in machine learning in the last 5 to 6 years, right? Including pre-training, reusing model architectures across different tasks and modalities, transfer learning. All of these things really took off in the last years. And now in retrospect, the results I was getting was actually showing the possibility there. I myself didn't connect the dots, but the overall research ecosystem that projects like Mind's-Eye and Aladdin funded enabled the researchers to follow through on some of these and make the breakthroughs that they eventually did. So overall, to me, I think in retrospect, I think the visual intelligence is basically a collection of all of these insights, tricks, hacks, all of that these hands-on research surfaces, and enable modern CV models to recognize diverse visual and multimodal concepts at different levels of abstraction. And also, there is an increasing trend towards smaller training data sets as well. So all of this to me represents visual intelligence rather than one high-level philosophical concept.
Got it. The problems that you're trying to solve here are just so incredibly interesting to think about how we're trying to identify and understand both what's happening in a video, but also, as you mentioned, this this visual intelligence, being able to understand what you're seeing is. I mean, this is something that I've spent a little bit of time reading about, but it's remarkable to hear about the ways that you're thinking about solving this problem and the efforts that you go through with it. And it seems to me like you've done quite a bit of work in your history on video analysis and event detection. I would love to know. I mean, obviously, you're now working on the Alexa team. I would love to know kind of how you're applying all of the stuff that we've been talking about and that you've learned over your history. How are you applying that to like multimodal Alexa and the camera that we have on the device and the interactions that we have there?
Yeah, I'm quite excited about the technologies we have been working on, right? That will further improve the experience we are delivering to our customers. So I can discuss a couple of examples. The first is natural turn taking, right? Where we leverage visual and audio cues to enable natural wake word-free interactions with Alexa. So, we have developed CV-based models to determine if a user is looking at the device or not. Similarly, we have also developed audio-based models to recognize if an utterance is directed at the device, and also reduce false wakes due to ambient noise or Alexa's own responses. And finally, we have also developed fusion algorithms that combine all of these cues and help Alexa to sort through utterances in a wake word-free multi-party conversation. So, maybe you and your spouse are talking to each other as well as Alexa to select a movie or something like that. How can Alexa automatically sort through all the utterances and identify the ones that are directed to the device and respond only to them?
Yeah, we saw.
Mhm.
Sorry to interrupt. We saw some of those features kind of highlighted when the Echo Show 10 was first launched. I noticed that in many ways the ways that we were showing that device being used were along those same lines, right? Multiple people standing around a kitchen, they're talking with each other, but then they direct something about, hey, tell me about this movie or tell me this thing. And the device was able to recognize when it should and shouldn't participate. I think is that a reasonable translation of what you're describing?
Absolutely. That's exactly what we are talking about, right? We announced it in the devices event in September 2020. And we look forward to offering this feature to customers pretty soon.
Oh, great.
Yeah. The second thing I wanted to also discuss in terms of what we are doing in terms of adding multisensory capabilities to Alexa is in augmenting calls between Alexa devices with visual effects, right? These include face stickers and style transfer. So Echo Show and other screen devices have played a major role in helping people stay connected, especially during the pandemic. I'm sure you have heard stories, and that is something we all at Alexa draw a lot of energy and pride from.
Yeah.
So what we have done is, we have developed CV and graphics technology to make calls with them even more delightful, right? This includes techniques that can be used to render realistic face stickers like sunglasses or hats, hot dog graphics that cover the whole body and such. And we also developed neural style transfer technology to transform the scene in a call. So in a call like this, you can make them appear like they are actually in a street art or a classic painting and many more. We have published some of our work here as well. In addition to building the product, we have also been doing some cutting edge research. We have published our work here at CVPR, and several scientists in the team have been inventing Rex and Ayush and several of those guys. And this was an oral presentation in CVPR. I don't know how much this means to you or a lot of the audience today, but for a computer vision researcher, getting an oral presentation in CVPR is like maybe winning the Oscar or something. So
oh my gosh,
I'm quite proud of what we did there.
Yeah, that's fantastic. It was interesting as you said that. You're like, yeah, we gave an oral presentation. I was like, oh, that's excellent, good job. I didn't realize that was that's a major honor, but I know at a lot of the science conferences, oftentimes you are just presenting a paper, an opportunity to read and then do some Q&A, but you're not up on a stage describing your work in detail.
Correct.
So that's fantastic. Congratulations.
Yeah, thank you. Thanks to all my co-authors, more than myself here, I think. Yeah.
Sure. So as we talk about multimedia processing and some of the things you were describing, how are we using machine learning to do that? And are there any issues that you confront in like training and deploying some of those models?
Yeah, absolutely. As you know, at Amazon, privacy is foundational to how we go about our work, right? And our CV models are no exception. With that in mind, we have developed techniques such as synthetic data generation to make our models robust to a variety of camera angles and lighting conditions. Further, we do not collect any image or video data from the customers to train these models, and have placed significant emphasis on developing on-device models as well. So those are some key things we have been looking at.
Cool. And I think that's really good to mention, because I know a lot of people are very aware of the fact that we do capture audio data to use to train a lot of our models. But that's not actually something that I had heard described, and it's refreshing to hear that we're not actually capturing image or video data to do the same thing. Because obviously that does capture photos and video of our individual customers and users, and without their permission, that seems like a massive overreach. So that's actually fantastic news to hear that we're not doing that.
Absolutely.
So we talked earlier about kind of the natural turn taking capabilities of Alexa and some of the things that you had worked on. With this capability, Alexa is doing more than just getting acoustic cues, right? I would imagine there's some visual cues that are mixed in as well to recognize when someone is facing or addressing a device. Can you tell me more about that?
Yeah, a significant breakthrough we achieved to enable natural turn taking is developing a machine learning system that can detect if an utterance is directed at Alexa, right? Without you having to say the wake word, right? So this sort of is the next step we want to take in making communication with device natural, right? We both have been talking for quite a while now, and I'm not calling you Jeff every time I'm talking to you, right?
Right.
So that's sort of the insight behind why we developed the system. And one of the challenge in developing this technology was to determine the target of a customer utterance, right? So say you and your partner and Alexa are in a multi-party conversation, and you say something like, how about watching a comedy movie? Is that targeted at Alexa, or are you talking to your partner, right? That's a pretty hard problem to solve for, right?
Sure.
So we had to take steps to make the system have also low latency so that we can accurately detect the start of such a device-directed utterance. And ultimately, we developed a system that used both audio and visual cues to determine when the speech is directed at Alexa, right? And also, as I mentioned, we have placed a lot of emphasis on on-device models for our CV technology, and that's true in natural turn taking as well. We developed a compact version of this model that runs entirely on device with minimal latency, right? And to prevent false wakes in the entity mode due to ambient noise. For example, you are looking at the device, so in that sense, the CV model is telling that there is somebody directed at the device, but maybe there is ambient noise or somebody outside the scene is talking that could be mistakenly interpreted as a device-directed utterance because I am looking at the device. So we developed audio device voice activity detection models to identify these sorts of false wakes and reduce them. Again, based on a model called convolutional neural networks that are also quite popular in CV. So in all of these cases, we conducted extensive experiments, like consistent with our dive deep principles and inventing on behalf of the customers. So we developed something that has minimal latency and high performance in terms of detecting these device-directed utterances.
There's two things that come out of that that I want to highlight. The first one that you mentioned was the idea that we're starting to move things, as you mentioned with latency, we're starting to move things to operate locally on a device, which means that it doesn't have to make that call out. It doesn't have to reach out to the cloud to get a bunch of additional information. It's actually making its interpretation there locally on the hardware, which obviously is a significant gain in latency because calling out to the internet can take half to a couple of seconds. That's well, one, that's remarkable, and that's fantastic news. The more I think that we can do those kinds of things, the better the experience will be for all of our customers. So that's fantastic. The second one that you called out was the idea of the combination of voice and audio gestures. Gestures is probably the wrong word, but the interaction between a voice and a face and the video and imagery that you're getting. How far have we taken that? I mean, if I were to just turn to my device right now, the Echo Show 10 that I have behind me, and I put my face right in front of it and I stare at it and I ask it a question, my suspicion is that's not going to respond to me, not until I say the wake word. Are there specific rules that users have to follow to get that kind of experience, or is this still research that we're working on that is not rolled out? Or maybe I'm completely wrong.
As I mentioned earlier in the talk, we look forward to launching these to our customers soon.
Oh, I see.
So in terms of how this will be made available and such, we will definitely communicate that when we make the launch announcements and such. But what I do want to again reemphasize is the significant invention that we have made in Amazon's unique customer obsessed way, right? We have developed cutting edge on-device technology for processing both the visual and audio signals to enable wake-word-free interactions, right?
Right.
We look forward to getting it in front of the customers and hear their feedback, learn from it, and continuously improve.
I look forward to that as well. That's those are exciting.
Mm-hmm.
All right, so we're gonna turn the subject a little bit to the topic of few-shot learning, which I know you've written a paper on recently.
Mm-hmm.
I know very little about few-shot learning, but pretty much everything that I've asked you about to this point, not only have you given a fantastic explanation, but you've increased my knowledge and understanding of these topics as well. So I'd love to know more about few-shot learning and kind of what this trend is.
Yeah. So again, I told you earlier, I'm actually getting a lot of energy working with various scientists on the team with various levels of experiences, right? I learn a lot from the senior VPs. I learn a lot from scientists on the ground. And this is one of those examples of the later, right? This was something I worked with my co-author Rakesh. It'll be useful to set some context of broader machine learning trends and concepts so that you can understand, what we did here. So, let's take a simple natural language processing task, right? Jeff is a principal evangelist at Alexa working for Amazon, right? So there are various things that you're communicating in that sentence that somebody might be interested in, right? Who are we talking about? What is their job? Which company are they working for? So on and so forth, right? So there are various entities mentioned in that utterance. And to build a machine learning model, how do you go about it? You annotate the person name is Jeff, the job name is Evangelist, the product name is Alexa, and the company name is Amazon, right? And you collect tens of thousands of these samples, maybe hundreds of thousands, and then feed it to a machine learning model that learns to recognize these entities from an utterance, right? Now let's take a completely different task, right? Maybe you want to automatically understand the sentiment expressed in a movie review, right? One person says about a movie, this movie kept me engaged throughout, and I came out excited after watching it, right? That's a positive review. Or somebody else says, this movie put me to sleep within the 5 minutes, and thankfully I didn't wake up, right? That's a negative review, right? And now to train a natural language processing model for the second task, you have to again go and collect a whole bunch of data and train the model, right? The first model you trained to recognize the named entities doesn't quite translate to the second task.
Sure.
Right? And you need to collect a lot of samples. So there's been a lot of excitement in the machine learning community recently around models like BERT and GPT that you might have heard. And what is happening there is something called pre-training, right? While task-specific annotated data is extremely expensive and hard to collect, there is a lot of free text available all over the web, right? So is there a way for you to use this large volume of data to pre-train a model, and then you can have some task-specific data that you can fine-tune this pre-trained model on, right? So that's a new paradigm for training machine learning models. And for the pre-training, what people do is they come up with a token task, right? Say for example, I told you, right? Jeff is an evangelist working for Alexa. I randomly mask off a few tokens, right? I drop the is, at, and so on and so forth, and say, can the model learn to predict the tokens I masked off, right? Or you can formulate it as a full reconstruction problem. Right? I take a utterance, drop some tokens, and then ask the model to reconstruct the full sentence from the sentence with the masked tokens that I gave. So there are different kinds of pre-training tasks you can come up with to leverage this large volume of data. And one thing we noticed is that often people pre-train the model using one particular task, right? Like the mask filling task I described, or reconstruction. And then when they want to train a task-specific model, like a question answering system or such, they use a different target from what they pre-trained to fine-tune on the task-specific data set, right? So what we showed is if you are able to formulate the fine-tuning task to be aligned with the task for which you pre-trained, then we can actually get very significant results in the few shot setting, where you only have a few examples, right? The sentiment recognition or named entity recognition tasks I mentioned. If you have only 16 examples of movie sentiment classification or 20 examples for named entity recognition in an utterance, how well can you take a pre-trained model and make it work on that task, right? Okay. And you showed very significant improvements on the benchmark QA data sets in the community. For example, a 34.2% absolute F1 score improvement with only 16 examples. And what we also showed is there's a trend towards training larger and larger models in the community, right? When BERT was launched, it had about 330 million parameters. Today, the largest model in existence that people have published about is about 550 billion parameters, right? That's how much people have increased the size. And what we showed is, first, we can make the small models be competitive with these large models that are super expensive to train. And also, the particular technique we proposed to align the pre-training loss function with the fine-tuning loss function continues to produce improvements even as we go up the size of the model, right? So those are two key things we were able to show.
Very cool. And so it seems to me like pre-trained models are probably the potential future of a lot of this work.
Yeah, in many ways, it's the present already, right?
Sure.
The BERT models, I think it was published in 2018, if I remember correctly. So it's just about three and a half years ago. But in terms of the overall consciousness of the NLP community, pretty much most of the work from before is superseded by these models these days. And definitely, yeah, it is good. If it's not all of the future, it's going to be a very significant chunk of the future.
Got it. And in this area. You had mentioned GPT as an example of that. I think that's something that probably most of our audience is at least familiar with. GPT-3. Those kinds of things are just that kind of capability just absolutely remarkable. To think about the fact that we can consume so much of that content that's available on the web and use it in a way to generate conversations and intelligence.
Yeah, and on GPT-3 and that sort of thing, there is also another interesting. I was talking about supervised learning, right, and then pre-training and fine-tuning. And GPT-3 was one of the earliest demonstrations of what's called prompt-based learning. So instead of giving samples and annotating them and fine-tuning your model, you can just describe the task, right? And give a prompt, and then the system can automatically produce an answer, right? It's not always perfect, it's still a work in progress. But the prompt-based learning is also a huge breakthrough. I think that's that I personally feel non-machine learning folks might catch on to faster than folks who are sort of deep in machine learning and still working in the pre-training, fine-tuning, or even supervised training framework.
Sure.
So yeah, a lot of exciting developments, definitely.
For sure. Well, so I was thinking we were going to talk a little bit about pre-trained models in the future, but it sounds to me like that's the present, if anything. So, I mean, you've been in this industry for a while, 20 years or so. I'd love to know, in all the advancements in machine learning and computer vision and things that you've seen over time, what do you think the big advancements over the next 20 years are going to be?
Yeah, I think the next major trend appears to be quite consistent, across all of the ML areas, right? Some of the notable trends, we already touched upon, right? Definitely further development of on-device processing. The second is around data efficient learning, right? Few or even zero shot, synthetic data generation, and also increasingly model interpretability and privacy preservation. So these are all, in my opinion, key trends. And these are all not secrets too, right? If you look at what top folks or practitioners in machine learning are spending their time on, these are the kinds of problems people are already spending their time on.
Very cool. All right, so I have a question that I usually wrap up as we talk with folks from our Amazon Science organization. Mm-hmm. And for many of the people that are watching this live, or maybe watching this as a recording later, I love to give them any career guidance or advice that you can offer. If you think about a research career at Amazon, what are some of the things that you would offer to people that might be considering joining us?
Yeah. So I would probably structure my answer into two parts, right? One is in general, if you are pursuing a career in machine learning, computer vision, and such, how do you go about it? And all of them apply to a scientist at Amazon. And what are unique things about Amazon that we definitely we are proud of here, and we want to communicate to our audience, right? The first is, as we have been discussing so far, key modeling techniques are starting to converge across different tasks and modalities. So I would definitely recommend researchers to not restrict themselves to any one modality and intentionally explore across different tasks so that they can surface novel insights and bring those insights across many problems, right? For example, the pre-training and transfer learning and all of these things we discussed about in the context of language models. A lot of the initial compelling results earlier in the 2010s were demonstrated in computer vision. And people spent a few years to see if the same thing can be done in natural language processing. And BERT showed, indeed, the results that people are seeing in CV is also transferable to language processing. And now language processing has really taken it to the next level, right? So I would suggest that intentional exploration across multiple problem areas. The second thing I would say is, especially people with an academic background, there is a tendency to over-obsess over achieving state-of-the-art results on some benchmark data sets, right? These data sets are absolutely helpful for the community to make progress, but small improvements in such data sets may not have a lot of real-world value. So I would recommend scientists to also develop strong experimental discipline and get the basics right. For example, are you clearly partitioning your data into train, dev, and test sets? Be sure you're not tuning hyperparameters on your final test sets, because that will give you misleadingly good results. And also, how often are you measuring performance on the test set, right? The more you do, the less valuable the gains you see are, because you as a human are already learning things about the data set by running experiments on those test sets.
Sure.
And also, how are you optimizing for hyperparameters? For folks in machine learning, they know what I'm talking about. And how sensitive is your model to them? If you change the hyperparameter from 0.1 to 0.15, suddenly the performance drops by 10%. Maybe your 0.1 result is also not very credible then, right? Most tasks in computer vision, all of these do need deep learning models, but many real-world data analysis problems do not. So take a hard look and see if your implementations can be simplified. And then be sure you are also able to communicate the simplifying effect that ML solutions have to other stakeholders, like engineers or product managers, right? Because I also hear that folks typically dive too much into the mathematical details when they're talking to people outside their field, and those other stakeholders often think that machine learning is too complex, and they end up accumulating a collection of rules and hacks in the production system because they offer the shortest path. But in reality, a well-defined machine learning model can eliminate a lot of engineering complexity, development, and maintenance time that a scientist should communicate and get buy-in from their stakeholders from, right? Yeah. This is general advice.
Sorry, I think that makes sense, because a lot of what I enjoy doing in having these interviews is being able to take kind of you went very deep with us on a few things. You were talking about specific parameters and values as you were training your models. I like to think that my job sometimes is to ask those kind of almost naive questions that are, well, how does this actually apply to the real world? Or how do we use this thing? Or how does that stuff come across? And I think that's really good advice for anybody that's thinking about being a scientist at Amazon, is that you need to be able to talk like a scientist to other scientists, but you also need to be able to translate that down to a much more understandable format for those that aren't.
Yeah, absolutely. So like, we talked about pre-trained transformer models, right? If I say BERT is using self-attention to pre-train on the MC4 corpus or something like that,
Sure.
That means nothing to you. But if I say that it offers a way to leverage unannotated web data, which can then be used for your natural language processing tasks with the smallest amount of training examples needed, that has value, right? I don't have to annotate a lot of data. That saves me money, and it's going to improve my performance on the task I'm interested in. So I want to learn more about BERT, right? Yeah. That's how a stakeholder will respond, right? So that's one, but that's also giving me a good segue, right? At Amazon, we are fundamentally a customer-focused company, right? At the company level, of course, we are focused on the end customers, but internally at Amazon, also, sometimes our customers are other partner teams, and we always want to identify who our customer is and work backwards from their use cases and develop technology that helps achieve an impact for our customers. So I would advise researchers at Amazon to always be aware of the problem you're addressing, irrespective of how you deep go into any specific algorithm or modeling approach, right? Always remember the problem. Don't get lost in the beauty of the models you're looking at.
Right.
Secondly, scientists at Amazon are deeply integrated into teams with stakeholders from diverse backgrounds, including engineers, program, and product managers, right? It's not a separated research organization or such. You are working with folks from other backgrounds. So definitely scientists should be able to work with all of them and be able to deliver results. Finally, at Amazon, we work on some of the most diverse and complex issues and projects across all areas of computer science, machine learning, and computer vision, right? We have real projects with real customers across the board in our initiatives, and we strive to delight them. So if all of this excites you, come join us. We look forward to you working with you.
Agreed. Thank you, Pradeep. I want to thank you for joining us today. This has been an enlightening conversation. I certainly learned a lot, and I hope that our audience did as well. For those of you that are watching, check out Amazon.science, the website, where you can find a host of published papers and blog posts where we've been talking about a lot of those things during this session. I'd also encourage you to check out the EMNLP 2021 page, which gives you the opportunity to view all of the accepted research papers at this year's conference. The content should give you more of a flavor of the kind of work we do here at Alexa AI, and you can always go to Amazon.science to get the latest on the new research techniques and published work from across our Amazon Science teams, including the work that Pradeep is participating in. So Pradeep, I do want to thank you one more time before we sign off here. I'm going to show a quick video that gives some people, this is a new one we've never shown before, but gives some people some insight on what it's like to work on the Amazon Science team.
The first word that comes to my mind when I think about the culture in Alexa is exciting. I constantly feel that I'm on the edge of the doable, that I'm breaking new ground, that I'm creating new things.
It's an environment of invention, of builders, of questioning what you've done. We definitely do hire people from a diverse set of backgrounds. We need a lot of different skill sets to make it work. We need all those viewpoints.
Even though it's been in the market for many years now, there's still like a lot of work to be done. And as you see, like there are like new devices coming every month or so. Each of those have different capabilities and different challenges. So basically that means that there's like a constant flow of like new problems to solve. So like it's never really done in that sense.
What it can do, the future, is even more exciting than what it has already done. And to me, that's the definition of a field that is still in its infancy.
people who come to Amazon will be looking at fundamental questions of what it means to be human, what it means to be interacting with a machine, and we'll be solving fundamental problems.
At Amazon, everything starts with understanding who your customer is and what they need, and working backwards from that into what it is that you actually need to build.
In my experience, it's been really exciting to be able to work on science projects. There are these great science mentors. There's even this Amazon Scholars Program where there are professors who split some of their time between university and Amazon, and I've been able to work with one.
First thing I would tell anyone considering a role in Alexa AI is get into Alexa AI as quickly as you can. It's a super exciting place to be, and if you want to do research in AI and if you want to connect that research into tangible real-world impact, this is the place to do it.